This is the United States Air Force Atlas, the most advanced intercontinental ballistic missile in the free world. Transformed from blueprints to flight with an urgency unmatched since the Manhattan Project. Identical in size and power to the Atlas that was hurled into orbit around the Earth, this missile is destined for flight test on the Atlantic Missile Range. The mission begins at San Diego, California, and it will end at a selected point in the Atlantic Ocean off Cape Canaveral, Florida. Other missiles are rolling off the assembly lines. Production missiles built with production tooling, scheduled for hot firings in the test stands at Edwards and Sycamore Canyon, and for shipment to Vandenberg Air Force Base on the Pacific Missile Range, Warren Air Force Base near Cheyenne, Wyoming. For this Atlas, the mission is flight, another in the series of tests needed before the Atlas is accepted by the Air Force as an operational weapon. Directed by the Ballistic Missile Division of the Air Research and Development Command, each test makes full use of accumulated information from all previous tests, and in turn adds one more programmed step toward the target. An I.C.B.M as reliable as man can make it. Thus, more advanced missiles are coming off the production lines even as this Atlas arrives at Cape Canaveral to begin its pre-flight checkout. From this building near Cape Canaveral, Air Force officers of the Missile Test Center and Ballistic Missile Division direct the coordinated efforts of military, scientific, and industrial missile launch teams. And this is the nerve center. From this vantage point, the Air Force directs all the vast complex of facilities known as the Atlantic Missile Range. A two-way flow of information is maintained over thousands of miles of telephone cable and radio links, connecting central control with the downrange facilities out in the Atlantic, as well as the installations surrounding the launching sites on Cape Canaveral itself. One of these, the Azusa system, uses high-frequency signals received by these 4 antennas to track and record the missile's flight path. Signals from the guidance center will make corrections in the predetermined flight path if they are needed. Telemetry antennas at Cape Canaveral will pick up more than 250,000 items of information on the performance of the mechanical and electronic systems radioed from the missile. At the launch complex, the missile is erected in the service tower for final checkout, controlled from the blockhouse, upper left, 700 feet from the firing pad. It is flight day -1, 24 hours to go. In the Windward Islands, 420 nautical miles southeast of Cape Canaveral, beyond Grand Bahama and Eleuthera, is the island of San Salvador, 12 miles long, 6 miles wide. San Salvador, where Columbus first landed, is Station 5 in the chain of 10 islands on the Atlantic Missile Range. Central control at Station 5 is tied in with all the downrange missile tracking stations by telephone cable or radio. Codename, the Kingston Net. Kingston 1 is central control at Cape Canaveral.
Kingston 1, this is Kingston 5, over. Here's a rundown on our Jane 85.1 being BEX.
On the day before launch, Station 5 checks out the tracking equipment needed for the test, according to an operational plan carefully worked out in advance by the Ballistic Missile Division's management, scientific, and industrial teams. These antennas on the receiver building will pick up flight information from the Atlas, readings on heat, vibration, pressure, engine performance broadcast from the missile's transmitters continuously during flight. At the guidance site, signals from beacons on board the Atlas will be transferred to magnetic tape. Just as a human voice can be transcribed by a tape recorder, the voice of each Atlas missile transmitting 250,000 items of information to ground stations is recorded for future analysis. With tape, each missile can be flown again and again in the laboratories, each microsecond of flight stretched out to yield every possible bit of information, improving the performance of each future Atlas. Here, during every second of the missile's flight, its exact position in space will be plotted and recorded. This computer will receive data from the Atlas, such as decreasing weight and surface drag, increasing speed and altitude, solve the equations involved, and instantly predict an impact point, while the missile is traveling many times faster than a rifle bullet. If impact prediction indicates the Atlas is off course, a signal from this command destruct console will trigger explosives aboard the missile and destroy it. Flight day -1 for Atlas. Instrumentation checkout at Station 5 continues. 830 miles down the line beyond Mayaguana, Grand Turk, and Puerto Rico is Station 9A, Antigua, in the Leeward Islands. Tracking installations at Station 9A include this Kennedy high-gain antenna, a duplicate of the antenna at Cape Canaveral. The Kennedy high-gain will track the Atlas as it rises from behind the curvature of the Earth and passes overhead toward the selected target area downrange. Radar, in phase with similar installations on the other downrange stations, will automatically track the nose cone after it separates from the missile, re-enters the Earth's atmosphere, and impacts on targets. In the receiver building at Station 9A, the timing instrumentation gets a checkout on flight day -1. Here, the measurement of time is precise. The equipment must be adjusted to compensate for the fraction of a second it takes each timing signal to travel through the telephone cable from Cape Canaveral. Timing. An exact means of common reference on all the charts and tapes recording thousands of items of related information during a flight. Timing is the key to the detailed study of flight test records. Preparations for flight tests continue. Information on local weather is relayed to Cape Canaveral from all the downrange stations. This constant flow of data enables the meteorologist to predict weather conditions along the entire 6,000-mile range. Beyond Antigua, 1,250 nautical miles from Cape Canaveral, there are only 2 island stations, Fernando de Noronha and Ascension. The gap is filled by specially equipped I.C.B.M ships, acting as mobile tracking stations. Working out of Trinidad, these ships take up their assigned positions before each Atlas flight. They carry telemetering equipment and radar to track the missile and to locate the nose cone data capsule in the ocean at the end of the flight. The search for the Atlas data capsule ejected from the nose cone will start immediately after impact. Search aircraft will be dispatched from Station 9A on Antigua to make a visual and radio search of the target area, guided by signals from a transmitter in the capsule. When the data capsule is located, it will be returned to Station 9A aboard this ship. All these operations at Antigua are coordinated from this building near the receiver site. Flight day -1 for Atlas.
Custom 9er Alpha, Custom 9er. I wish to verify with you or to confirm for you that the telemetry link frequencies are the 5 link frequencies spelled out in Part 2 of the OD and not the 6 link frequencies spelled out in the table of frequency utilization. Do you understand? Over.
Custom 9, this is Custom 9 Alpha, reference your last, Roger, understand the 5 frequencies we were using. I believe we had this once before. Over.
Custom 9er Alpha, this is a Custom 9er. You are correct. We
Station 9A is the assembly point for flight information recorded on the I.C.B.M ships. Here, telemetry tapes from another missile flight are delivered for immediate airlift to Cape Canaveral. These same aircraft are also used to assist surface ships in locating nose cone data capsules from missiles. They carry 2 flight crews and 4 observers and are specially equipped for long overwater flights to downrange impact areas. They operate out of Patrick Air Force Base near Cape Canaveral. At installations on all the islands of the Atlantic Missile Range, final preparations continue for the Atlas flight test. Flight day -1 at Cape Canaveral. The missile is in the service tower on pad 13, one of the 4 Atlas launch complexes. All missile systems have been checked out, and the engines have been test fired. The payload is placed in position.
Pull it over to the other side for you, Oscar.
When this nose cone is automatically separated from the missile at a predetermined point in space, the natural laws of speed and gravity will direct it in an arc to its target. The contents for this trip are recorders and research equipment in a data capsule.
Roger, go ahead.
The exact point of impact is measured by 2 different electronic systems to ensure accuracy. The missile's flight path before nose cone separation will be visually recorded on these maps and charts at central control. In the Convair telemetering trailer, final adjustments are made on the electronic equipment used to receive and record flight information. At all the stations on the Atlantic Missile Range, preparations are complete for the Atlas flight test. Flight day, filmed and recorded just as it happened.
Attention, please. All personnel not conducting tests, please clear the test stand area.
Test conductor, this is test stand.
Go ahead, test stand.
The boot has been sewed up completely around the booster. The service tower is in the process of being moved to the transfer table.
All right, yeah.
Goes in over on the exhaust tube side.
LN2 spray manifold is on. Test stand looks in pretty good shape, Tom.
GE guidance, this is the Conrad test conductor.
Test conductor from GE, Gag.
Fred, we would like to confirm our regulators before proceeding past this point.
Tom, we'll be ready for loop test at -80.
Okay, Fred.
Test conductor, this is our system.
Go ahead, Conrad.
We have satisfactorily completed the range safety command test.
All right. Port coordinator, test conductor, over.
Bad test conductor.
Frank, how's this local shower now?
Wait one, I'll make a check.
Test conductor, this is pad safety.
Go ahead, Pat.
I just got a report from the weather people. They don't anticipate too much, too excessive lightning in the area, so it looks pretty good.
Okay.
Test conductor, support coordinator.
Go ahead, Frank.
This rainstorm is dissipating. The electrical activity is moving south. They expect this to be over with in about 20 to 30 minutes. I will give you another report in about 20 minutes.
Thanks, Frank.
Test conductor from GE guys.
Go ahead, G.
Test conductor, on further checking, I'm sorry to tell you that system 2 is no-go at this time. Only estimate I could give would be about 30 minutes to try to determine what our problem is.
All right, stand by.
Test conductor, telemetering.
Go ahead, telemetering.
Telemetering's all go.
Thank you.
Test conductor, support coordinator.
Go ahead, Frank.
You have 100% optics.
Okay, Frank, thanks.
Test conductor, this is test stand.
Go ahead, Jim.
Tom, all checks out okay over here. We're evacuating the test stand area.
All right.
35 and counting.
Test conductor from GE guys.
Go ahead, G.
Mod 2 space check completed at all stations, okay.
All right, Jim.
Test conductor, locks control.
Go ahead, lock control.
Lock systems ready for tanking.
Okay, proceed.
Roger.
T-minus 30 and counting.
T-minus 30 and counting right now.
Roger 5.
Counting on time. Over.
This is 9 Alpha. Understand, you are counting on time. Instrument status from this station is all A-OK. Aircraft status, all A-OK. Over.
Kingston 9 Alpha, Kingston 9er, roger. Thank you very much. Out.
Test conductor, pad safety.
Go ahead, pad safety.
Okay, we now have a clear launch area.
Thank you.
Minus 15 minutes. Mark. This is 1.
Kingston 1, this is Kingston 9er. I wish to advise that radio interference reported earlier by this station has now cleared. We have loud and clear communications with all ships and stations. Over.
Roger, thank you.
Minus 4 minutes. Mark.
Water panel, periscope.
Roger.
Throttle valve open, please.
Throttle valve coming over.
Minus 50. Azusa.
Go.
Joseph.
Go.
Beacon.
Go.
G guidance and IP.
Go.
G nose cone.
Go.
AFMTC telemeter.
Go.
Telemetering quality.
Go.
T-minus 3 minutes and 30 seconds in counting.
Turning water systems on.
Missile internal AC.
Water flow satisfactory.
Jumping LN2.
Minus 2 minutes. Mark.
Switching range safety beacon and commands to internal.
Minus 150.
Boom is stop.
Telemetering system to ready.
145.
Test off on switch to arm. Arm light on.
Engine pressure
be let on
engine test. Missile AC, internal DC.
135. Nose cone report switched to OK. 130.
Securing locks tanking.
Minus 120.
Removing arming safety pin. Arm switch to arm.
T-minus 60 seconds and counting.
Mark.
Missile helium to internal.
Steady.
Minus
As you go,
55.
Range ready, switch on.
You have a line down.
50. Nose cone
Starting
bevel
foam
check.
removal.
Missile prep complete on engine test.
Status check.
It's not coming out.
Locks tanking.
So it won't come out.
Pressurization.
Satisfactory.
Water systems.
Satisfactory.
Range operations.
All clear.
Nose cone foam.
Clear of missile.
All the pre-start panel lights are green. The missile prep complete light is green. All recorders to fast. T-minus 25 seconds to counting. Burn your start. Burn your start light.
25 seconds counting.
Telemetry.
Minus 20.
Counting. What is that on the money?
20 seconds.
Take 2 starts. 15.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2,
Track looks good as under control.
Looks good.
Plus 60 seconds.
Our system's still on track here.
Programming over.
Azusa still go.
Plus 90 seconds. SRO, are you still tracking?
Yes, sir. Things are looking real fine.
Okay, Jim.
You got a real runner there.
Good.
Plus 2 minutes.
Impact prediction looks good.
Just went behind the clouds.
Mark 1. Mark 2.
That's separation.
We got separation.
Yep.
Still going. Separated.
IP system downrange locked on. Radar at station 3 has track.
Plus 230.
Radar at station 5 has track.
Kingston 1, this is Kingston 5.
Telemetry on signal on recording at 17:45.
Impact prediction still moving out.
167. On signal at 1718.
How's the sustainer telemetering?
Plus 330.
Still have sustainer, still have verniers.
Hot dog.
Kingston 1, this is Kingston 9 at 1901.
Track prediction has stopped.
Plus 4 minutes, 30 seconds.
Mark 5.
All the way, boy.
Mark 5. The nose cone is separated from the missile and is traveling toward the target at more than 12,000 miles an hour.
55 seconds. Kingston 9 Alpha advises telemetry on signal, recorders on.
1733, radar transmitters off.
Kingston up and Kingston 5, over.
Go ahead, 5.
This is Kingston 5, and our telemetry recorders off at 1733.
Item Bravo as follows. William north. Item Roger, Dog Baker west.
That's affirmative, and paragraph Charlie is green.
Impact. On target. A selected point on the surface of the Atlantic Ocean. The big target is the development of an I.C.B.M. as reliable as man can make it, capable of instant retaliation against any objective on the surface of the world. Each atlas, from the flight records it leaves behind, gives this country information we need to reach this goal. It is flight day -1 for the next test on the Atlantic Missile Range. Right now.